We did double angle formulas, and then we started to do some examples with half angle formula. So just to remind about our double angle formulas, I'll write these off to the side here. We had sine of 2, I'll write it as x, is 2 sine x cosine x. We have cosine of 2x, has 3 different forms. So you've got cosine squared x minus sine squared x, 2 cosine squared x minus 1, and 1 minus 2 sine squared x. And then finally, we also had tangent of 2x, and that was 2 tangent x over 1 minus tangent squared x. Pardon me. And we did some examples with those last time. Where these things pop up, we'll see the cosine of 2x1 pop up in the next section after the exam when we do some equation solving and want to try to convert cosine. Usually we'll use one of these other two here to convert cosine into either cosine of x or sine x to help us solve the equation. We'll see that when we get to it. We'll see that pop up. Other reasons why these will pop up come up later in calculus, for example. In any event, those are what we talked about last time. We also talked about the half angle formulas. I usually write it this way, so I don't have to write the fraction in there. The important thing is, if you're using the half angle formula, is that the argument in here is half of the argument over here. That's why it's called a half angle formula. Remember that this is not truly a plus or minus. You don't get two answers. Even though we write plus or minus, we don't really mean what we ordinarily mean from plus or minus. We don't get two answers. We have to make the decision, is it positive or is it negative, depending on what quadrant the input is here. Okay? So if this is in quadrant 1 or 2, then it'll be positive. If this is in quadrant 3 or 4, it'll be negative. Over here, if it's in 1 or 4, it'll be positive. If it's in 2 or 3, it'll be negative. This is not your traditional plus or minus. It's not both possibilities. It's you have to make a choice. Is it positive or is it negative? Okay. All right. So let's see if we can do a couple more examples with that. So we've got sine of 7 pi over 8. Sine of 7 pi over 8 is not one of those angles that we know the exact value of, right? Okay. So we need to use one of our, pardon me, one of our half angle formulas to help us out with that. We notice, though, that 7 pi over 8 is half of 7 pi over 4, right? Again, that comes from the formula we just talked about a minute ago. The input here is half of the input here, right? I personally like to think about it the other way around. I take this input and I double it. And now I do know this value, don't I? I know how to do cosine of 7 pi over 4. Right? Okay. So a couple of things now we need to do to help us simplify. First, I need to determine, is it positive or is it negative? And the second thing I need to do is finish off this and figure out what the exact value is. Okay? So first, is it positive or is it negative? Well, I look at this angle and I ask what quadrant is that in? It's in second quadrant, right? Is sine positive or negative in quadrant 2? Positive, okay? So we'll get rid of the negative and use only the positive. 7 pi over 8 is in quadrant 2. It's a pi over 4 angle. Cosine of pi over 4 is 1 over root 2. And then I just need to determine, is it positive or negative? 7 pi over 4 is in quadrant. A little bit farther. I think 4, right? You know, because it goes 1, 2, 3, 4, 5, 6, 7. Yeah, so we're in quadrant 4, so it'll be positive. So we get that for our answer. Now, the only thing that's going to change, at least to start with, for this one, is we want to use the half angle formula for cosine to start. Instead of a minus sign in the middle there, our half angle formula for cosine is a plus sign in the middle, right? The half angle formula for sine and the half angle formula for cosine are almost identical. The only thing that changes is that plus sign in the middle. And now again, we have two things to figure out. Should I use a positive or should I use a negative? And then what is cosine of 7 pi over 4? We already did that a minute ago, so that one's not hard. Okay. So in this case, literally the only thing we have to figure out is it plus or is it a minus? Which is it in this case? Because? Good. Again, same answer we had before. 7 pi over 8 is in quadrant 2. And this time we're doing the cosine rather than the sine. So our final answer will be negative 1 plus 1 over root 2 over 2, or you could write it as root 2 over 2. And again, I don't care if you simplify the complex fraction into the radical. This tells me you know how to do the problem. Unless you know how to do the problem, I'm happy. It's okay? All right. We did not, I don't think, derive our formula for tangent of 2x because I was trying to get to some examples last time. So let's go back a page and see if we can develop our formula for the half angle formula for tangent. A couple of ways to get at it. I think probably the easiest way to get at it in this case is, what do I want to do here? I wrote 2x in there. I'm not sure I want to do it that way to start with. What happened? What's the worst that happens? I do it wrong? All right, so we have, I don't want to do it that way. That's going to be ugly to try to solve for. Notice that I should have proofread this before I printed it out. Notice that before we were using the cosine double angle formula and realized that this inputs half of that one and then solve for it in both cases, right? That was how we got the half angle formula for cosine by using the 2 cosine squared x minus 1 formula. And then the same thing here for cosine of 2x. For tangent, I think I want to start with not tangent of 2x. Let's just cross that out. I want to start with tangent squared x. Let's start there. I think I tried to put that as an exponent when I wanted to do this. All right, anyway. So one of our tried and true methods for trying to deal with something with tangent is write it in terms of sine and cosine, right? Him? Okay. Pardon me. So now we can use our power reducing formula, if you will, our our half angle formula for sine and cosine to replace the top and bottom. And since I have squareds on there, I don't need to worry about the square root right away. I can rewrite the top here as 1 minus cosine of 2x over 2. In the top, I can write as 1 plus cosine of 2x over 2. What can you do with the 2's here on top and bottom? What happens to those things? They cancel, right? Because if you think about inverting and multiplying, this 2 goes up to the top and then they would cancel out, right? So this just becomes 1 minus cosine 2x over 1 plus cosine 2x. And this actually gives you a perfectly good half angle formula for tangent. You could take the square root of both sides and you would get plus or minus, and then again decide on which quadrant you want, right? But there's a couple of nicer forms than this. Okay, so let's see what we mean by that. We've done this trick before where we've multiplied by the conjugate. So let's multiply top and bottom by the conjugate of the bottom. What does the bottom become then?
Minus cosine to the 4th x.
Those are 2x's, not squareds.
Oh yeah.
Yeah, so it's just cosine squared of 2x. Yeah. So the argument doesn't change. I just have cosine 2x times cosine 2x, which gives you cosine squared 2x. Notice I haven't touched anything on top. I just have the same thing multiplied by itself. So I get a 1 minus cosine 2x quantity squared on top. However, now what can we rewrite the bottom as? It's 1 minus cosine squared, so it's going to be sine squared. Yeah, it's sine squared of 2x, right? The argument doesn't matter, correct? It's whatever you plug in as long as it's the same. Oops, sine squared. So notice we have perfect square on the left-hand side. I now have a perfect square on the right-hand side. So when I take the square root, I get 1 minus cosine 2x over sine 2x, 2x. Now technically, whenever you take the square root of both sides, you should always get plus or minus, right? But remember, it's not a true plus or minus. Remember when we're doing these, it depends on what quadrant the x is in, correct? For the tangent, right? Well, notice that if it's in quadrant 1, if this is in quadrant 1, pardon me, goodness. It should work. What am I doing wrong? Oh, that's right. Okay, notice that, sorry, I was thinking about this backwards. What's the smallest this can ever be on top? What's the smallest value that you could ever possibly get on top? Think about it this way. What's your cosine always in between? When you take the cosine of something, it's always in between what? 1 and negative 1, right? Well, if this is always between 1 and negative 1, the biggest thing you can ever subtract off is what? What's the biggest thing you could ever subtract off? 1. So the smallest this could ever possibly be is the biggest thing you can put in for cosine of 2x is 1. And you do 1 minus that, the smallest thing you could ever get out is 0, right? Yeah, the biggest you could ever get is 2, but the smallest you can ever get out is 0, right? So is that, in particular, is that ever negative? No, that's never negative, okay? This is only negative, so the only way that this expression can be negative is if the denominator is negative. That's the only way it can be negative, right? Okay, so let's go back to what I was talking about. If this is in quadrant 1, if you're between 0 and pi over 2, I double that. You're in between 0 and pi, but sign is positive there, right? So this would be positive then. If you're in quadrant 2, you're between pi over 2 and pi. This would be between pi and 2 pi, which would make this negative, so they match, right? If this is in the third quadrant, this will be between 2 pi and 3 pi. It'll be positive again. If this is in quadrant 4, that'll be negative again. The whole moral of that story is I don't have to worry about the plus or minus. This is the half angle formula for tangent. Okay. Or I should say this is a half angle formula for tangent. I can rewrite this as something else. I don't need, even though we took the square root of both sides, remember it's not a true plus or minus, it's I have to make a decision plus or minus, right? But the good news is that this quantity makes the decision for me. I don't need the plus or minus. Remember again, even though I have it written as double here, this is half of this. That's the important, that's why it's called the half angle formula. The other form that you might see for this, notice we started this whole discussion by multiplying by 1 minus cosine 2x. We did the conjugate at the bottom, right? You could have also started with the conjugate at the top. And if you went through that whole explanation that I just did, you would have got this. Okay, so that's another form of the half angle formula for tangent. It's the same exact derivation that we just did. Just multiply with the conjugate at the top rather than the conjugate at the bottom. You'll get the same answer. So let's see if we can put this to use along with the other ones. Let's scroll down to this next example. And we'll also do tangent of alpha over 2 as well for this one. All right. So this looks like one of the other problems that we've seen before, where we have a trig function of an angle given. It tells us what quadrant that angle's in, and then it asks us to figure out trig functions of that angle, or functions of that particular angle. All right, so again, the first thing I want to do is use my information here and draw a triangle. So for this one, they tell me that my angle is between pi and 3 pi over 2. So what quadrant should I draw my reference triangle in? 3. We're given that cosecant of alpha is negative 17/15. So what sides can we label?
17 and negative 15.
Okay, 17 is the, and the negative 15 is opposite. Good. We can figure out the adjacent side using Pythagorean theorem. Using your Pythagorean theorem, you should get negative 8. All right, so let's go with our half angle formula. So remember again, the reason why we call it half angle formula is because of problems like this, right? When we apply the half angle formula, what goes inside is going to be double what's here, right? If I double what's there, I get alpha, don't I? Okay. So using our half angle formula, we should have plus or minus 1 minus cosine alpha over 2. And if you want to memorize your half angle formula by using alpha over 2 here and alpha there, that's fine. I just don't like writing the fractions. I just need to remember what's under the radical inside the cosine is double what's inside on the other side. All right. So using the triangle, we can certainly figure out cosine of alpha, can't we? What is cosine of alpha?
Negative 8 over 17.
Good. So I'll get 1 plus 8 over 17 because I'll have minus a minus there, right? Okay. Now the last thing I need to do, and that's why I haven't written anything out in front here yet, I need to determine whether it's positive or whether it's negative, right? What do I look at to determine whether it's positive or negative? What do I have to look at?
Alpha over 2.
The alpha over 2 and figure out what quadrant it's in, right? That sounds hard, but it's really not. Okay. Where do we know about alpha? Alpha is between pi and 3 pi over 2. So what's alpha over 2 in between? Good. Just divide everything by 2. Divide everything by 2. We get that expression, don't we? Where does that say alpha over 2 lives if it's in between pi over 2 and 3 pi over 4? Second. So what's it going to be, positive or negative then? Positive, good. Because alpha over 2 is in quadrant 2. So what I have at the bottom is right. I don't need to worry about putting a negative in front of it. Okay. How does that change for cosine of alpha over 2? What was your formula going to start as?
Plus sign instead of minus sign.
Yep, good. It's exactly the same formula, except that it's a plus sign instead of a minus sign. Literally the same formula, except that one change. Just have to remember which one's which. Okay. We already calculated what cosine of alpha is. Oops. It was negative 8/17, right? So I'll have 1 minus 8 over 17 over 2. Then the last thing we have to determine is it positive or is it negative? Well, you just told me a second ago alpha over 2 is in quadrant 2. So do we use the positive or do we use the negative? Negative. let's do one more, even though I didn't write it on here. I should have. What if I asked you for tangent of alpha over 2? We just wrote down what a half angle formula is for tangent. You got 2 of them, as a matter of fact. And use 1 minus cosine alpha over sine alpha. Remember again, when you're using the half angle formulas, the expression that you're writing typically on the right-hand side of the equation, the inputs there on the right-hand side are double the input on the left-hand side. So a half angle formula for sine, on the right-hand side when you write it down, the input is half of that, right? Or the input is double on the cosine. Well, we figured out what cosine of alpha was, didn't we? It was negative 8 over 17, and sine is negative 15 over 17. And again, you could simplify it if you want to. I do not care. Is that one okay? Does it make sense what we're doing with those? Okay. All right. So we've done double angle formulas and we've done half angle formulas. We're going to do one more type of formula, and then this is last, because we got a lot of formulas for this chapter, don't we? This will be the last formula that we talk about, and this is referred to as your book calls it product sum. A lot of books will call it product to sum formulas. All right. So the idea behind the product to sum formulas is that you've got a product of sine and cosine with different arguments, with different inputs, and you want to try to rewrite it as a sum of 2 pieces of, say, sine of something and sine of something else, or cosine of something and cosine of something else. The reason behind why we care about this is because it pops up in calculus. Really, the reason why we even care. Okay. But we'll talk about how we do it because it's a nice application of our sum formulas, addition formulas for sine and cosine. Pardon me. So just to write those down again, if I want sine of alpha plus beta, what's that equal to again?
Sine alpha cosine beta plus sine beta cosine.
Good. And your cosine of alpha plus beta?
Cosine alpha cosine beta minus sine alpha sine beta.
Okay. And then, of course, if we put the minus in there, it'll flip the sign in the middle, right? If we do alpha minus beta, it'll just flip the sign in the middle. Okay. All right. So the idea behind this is that I'm going to use my sum and my difference formulas to help me get an expression for this. So here's how that's going to work for sine of alpha cosine beta. Let's do this first. You just told me what this one was. And you just told me that if I do a subtraction, all it does is flip the sign in the middle, right? Correct? All it does is flip the sign in the middle? Cool. I'm trying to find a formula for that thing up there that I wrote. I want to find a formula for this piece that I just put a little box around that I'm going to erase here in a second. I want to find a formula for that part, right? what can I do with these two equations so that I can get a formula for this and at the same time make this go away? What can I do with the two equations in particular to make that thing on the right go away? Yeah, just add them. Yeah, exactly. Just add down, right? If I add, they have opposite signs already. So if I add down, they go away, don't I? So notice if you have sine of alpha plus beta and add sine of alpha minus beta, how many sine alpha cosine betas are you going to have if I add? Two. Good. Yeah, it wasn't a trick question, right? They're two like terms, aren't they? And then the other ones go away. I said I wanted an expression for sine alpha cosine beta. I've got an expression for 2 sine alpha cosine beta. What do I need to do now to get to the final step? Divide by 2. Yep, that's all I need to do. Good, fantastic. So your sine alpha cosine beta is 1/2 sine alpha plus beta minus sine of alpha minus beta. Generally speaking, it's easier to deal with a single function of a single argument, which is what we have here now, than to deal with a product of two functions that have different arguments. Okay? That's why we do this. In particular, in calculus, it's easier to deal with this from a calculus perspective than it is to deal with this. You won't see it for a while, and when you do see it, you probably won't even remember we talked about it, but that's why we do it. Plus, it's fun to play around with algebra stuff, which is all we're really doing. I'm an algebraist, so my formal training is doing abstract algebra things. So for me, playing around with symbols and pushing them around, I'm a symbol pusher. It's what I do. Professionally, what I do, I push symbols. All right. So that is our product to sum formula for that combination of sine and cosine. So let's do an example with that. I should have an example on the next page with that. And then we'll come back and do the other ones. So this one asks us to rewrite sine of 3x cosine of 5x as a sum. So we've got that mixed 3x, we've got the mixed sine cosine piece, right? So that's going to use the formula that we just came up with. So this is our alpha and this is our beta. So according to the formula we just came up with, what are we going to have on the inside of that first sine? Good. 3x plus 5x. And on the second sine, we'll have 3x minus 5x. Good. So we get sine of 8x plus sine of negative 2x. And just to illustrate another one of our identities that we've had, when I have sine of an opposite of an angle, what can I do with the negative sign? Put it out front, right? Because sine's an odd function. So just to make it a little bit nicer, we can write this as sine of 8x minus sine of 2x. That's okay? Does that make sense what we're doing there? Okay. So anytime you've got that mixed sine cosine piece, you're going to use this formula. All right. So let's see if we can go when we've got the same function in both pieces. So scrolling back up here, notice I've got a sine alpha sine beta and I've got a cosine alpha cosine beta. Well, looking at our formula for cosine, notice that your formula for cosine has cosine alpha, cosine beta, sine alpha, sine beta, right? So I'm going to use our sum formula for cosine to help us out here. So let me write down the formula for both the sum and the difference, just like we did in the previous example. And this is going to be the same thing we want to look at in doing both of them. And had I thought a little bit more when I typed this up, I probably would have done the cosine first and then the sine, but that's okay. We can figure it out. So remember when we developed the one for sine alpha cosine beta, we said we wanted the sine beta cosine alpha to go away, right? Okay. Same premise here. I want a formula for sine alpha sine beta, right? I want the cosine alpha cosine beta to go away. What do I need to do with the equations to make the cosine alpha cosine beta go away? Subtract them, right? That'll make the cosine alpha cosine beta go away, won't it? I'll do the bottom one minus the top one because it'll make that sign a positive. Okay. The only reason why I'm doing bottom minus top. Okay. So if I do cosine of alpha minus beta minus cosine of alpha plus beta, we get 2 sine alpha sine beta. Just like what we had in the previous one, isn't it? And then again, just like we did in the previous, we will divide by 2. And get that. Of course, I guess in the previous one I wrote brackets rather than parentheses, but I'm assuming you're okay with grouping symbols. It's okay? All right, let's do the other one now, and then we'll go do the last 2 problems, and then, given the time, I think we'll call it a day. This is already 10 minutes left of class. Time flies when you're having fun. You all look like you're having a ball this morning. All right. Instead of subtracting, notice it down here on this one. Instead of subtracting so that we got rid of the cosine alpha cosine beta, what do we want to do now to get rid of the sine alpha sine beta? If we're doing one for this one. Add them together, right? So now when we add your cosine of alpha plus beta plus cosine of alpha minus beta, we'll get 2 cosine alpha cosine beta. And then like we just did in the previous ones, divide by 2. We get that. Okay. All right, so let's see if we can apply these. This one asks us to rewrite sine of 2x, sine of 7x as a sum. So what do we get here?
Cosine 2x minus 7x minus cosine 2x plus 7x.
Good. Yep, I agree. So if we simplify a little bit, we should get cosine of negative 5x minus cosine of 9x inside the parentheses there. And then just to remind again, if you have cosine of the opposite of an angle, what can you do with the negative?
Take it out.
Just take it, just make it go away, right? Because cosine's an even function. So cosine of the opposite of an angle is just the cosine of that angle. Okay. So we can just rewrite this as 1/2 cosine 5x minus cosine 9x. Versus, if we do the last one here, what would we have here? Okay.
Plus cosine 2x minus 9x.
Good. And then if we make it a little bit nicer, you have cosine of 11x plus cosine of negative 7x. And then again, since cosine is an even function, cosine of negative 7x is the same thing as cosine of 7x. Main reason why I'm doing that last little bit is just to remind you about the even odd identities. Question on those at all? Like I said, right now, it doesn't seem like there's a lot of point to doing this. I agree. It doesn't seem like there's a lot of point to doing this because literally this is all we're ever going to ask. I'm going to ask you to do is math. Right? So, on Wednesday, we'll just review for the exam. Sound like a plan? Because this is the last thing that's on the exam. So, I'll have a review sheet. We'll remind the sections that are on there, but I'll go ahead and remind now. Section 7.1 was verifying identities. Section 7.2 was the double, half, and try it again. Was the sum and difference formulas. And then section 7.3 is your double, half, and product of sum formulas. So that is what the exam will be over, just those 3 sections. Okay. So we'll have a review on Wednesday and exam on Friday. All right. Have a good one, everybody. We'll see you on Wednesday, if not before. Yeah, absolutely.
Right.